Okay, so in this last video, I want to talk a bit about file permissions. So if you go through in your terminal and type ls-l, this prints out that long form output of ls. And at this point, we now have the tools to understand basically all of this output, right? Starting from right to left, you have the name of the file, the date it was edited, its size in bytes, the group it's associated with, and the user it's associated with. So it turns out that every file is owned by a user and is also kind of associated to a particular group. And I think it's possible to be associated to no group, but they're usually just a default group that it gets set to. But then there's this kind of string of weird looking R's and W's and X's and D's on the left. This string kind of weirdly encodes the permissions on the file. So I'll explain in this video how to read this and know what the permissions are for any particular file. Knowing the user and which group is associated to a file is really important when it comes to understanding who is and isn't allowed to access it. And this string is kind of telling you exactly who is and who is not allowed. So I'm going to switch to my slides, which show a nice description of how to read this string. So this string is 3 groups of 3 characters and 1 extra character at the front. That first character is a D or not, indicating if the file is a directory or not. So if you look at this output, the cows has a D in that first position because it's a directory, and all the other files don't because they're not directories. So this is one way of knowing if a file is a directory or not. You can see this D flag in this kind of string. Now, that one isn't the most interesting. The other 9 characters are the ones that are really interesting. So these other characters determine who can read a file, who can write to it, and who can execute it. Execute meaning like run it like a program. So like use it like a command in bash. So every file has read, write, and execute permissions. But that's usually not enough because you need to know who can read it and who can write it. And you might want that to be different for different groups of people. And so every file has 3 sets of these things. 1 for the owner, 1 for the group, and 1 for everyone else. So when you have this kind of 3 characters at the front, RWX, this is saying which permissions the owner of the file has. So if you see R, it means they can read, W means they can write, and X means they can execute. So if you see RWX here on a file, you can see what is runnable and what's not. So for example, you could see that I, the owner, have read-write access to this file, run.sh, but don't have execute permissions. Meaning if I try to run run.sh, which you can run like this, it says permission denied because I don't have the permission to do that. You might be wondering, well, what if I want to change the permissions? Can I do this? Yes, you totally can. We'll talk about that in a second. But these other parts of the string determine other people's permissions. So the next string of 3 is RWX for whether the group has permission to read, write, or execute. And that could be useful, for example, if I want to have my TAs also have write access to a file, then I want to make sure that it has a write permission for the group, not just the owner. And then others is everyone else on the system. That's not the user, that's not in the particular group associated with the file. And is this globally readable? Is it globally writable? Is it globally executable? In which case, like my CSE website files or my 391 website files, I don't want those to be globally writable because then anyone can edit my course. And I do not want that, but I do want them globally readable. And so the way you read any of these strings is just this first character for whether it's a directory or not, and then these groups of 3. So if you look at this run.sh, the owner, me, has read, write, and not execute permissions. My group, faculty CS, has read, but not write or execute. And then everyone on the system has read, but no write or no execute permissions. So um, this this whole everyone else category also gets a little bit weird when you start thinking about the permissions of directories, which we'll get to later. But in some sense, if someone got access to this file, anyone would be able to read it, but they wouldn't be able to write to it unless they were me. Now, you might be wondering, as I kind of alluded to, how do you change the permissions on a directory or on a file? So what if I want this run.sh to be executable? That's where we use the chmod command. Chmod lets you change the permissions of a file. And it has a kind of fun looking syntax for changing permissions. What you do is you say which category are you trying to affect. Each one of these categories, user, owner, group, and others, have a letter associated with them. Kind of confusingly, the owner is associated with the letter U, probably for user. Group is G and others is O. And so you can use this kind of shorthand letter to describe kind of how to change the permissions of a file. So you might say something like user plus X. Give the user plus the X permission for the user section. And I'm going to do on run.sh. If I do ls-l now, you can now see I have R, W, and X permissions because I just added for the user the executable permission. And so now I could run run.sh, which just prints out zoom zoom. So this little fancy syntax for chmod is really nice. So for example, you can do multiple things. So what if I want to give my group write and execute permissions? Well, I can use G for group and then plus X and W to add both of them to run.sh. And now if I do ls-l, you can see run.sh has read, write, and execute for the group. And again, this little the fact that you use U for the owner is a bit weird, but it's because O is for other. So I gave the user here plus X permissions. And you can combine these in many ways. So you could do something like chmod, and maybe I want to remove read and execute permissions from the group. And then maybe for everyone else, I want to add write permissions, so O plus W. So minus takes away permissions, plus adds permissions. In some sense, these commands don't care about the current permission of the file. Like if you add something that's already there or remove something that isn't, it doesn't crash or anything. It's just going to stay removed or stay added. But you can always just be more explicit if you want to be clearer, make sure that the permissions are the way you want to. So this command is going to remove read and execute from the group and add writing for everyone else. And if you do ls-l, you can see the string changed appropriately. Now, you might be wondering, okay, well, if there's this notion of permissions, but I'm able to change them at will, what's the point of having user level permissions if I can just change it? In some sense, this is a form of protection, because if you set up a file to have certain permissions, you can stop yourself from accidentally shooting yourself in the foot. So for example, maybe that run.sh, when I installed it, maybe I wasn't quite certain if it was actually a safe program to run. So one thing I could do is temporarily disable run execute permissions on it. So there's no way I accidentally run it, because if I try to run it, I don't have permissions. This more commonly is if you have a file that you know you don't want to write or edit, then you can protect yourself. So for example, if I take away my write permissions from run.sh, oops, not run, chmod, then I can't do something like add, echo foo, and add it to run.sh. I don't have write access to this file, so I can't edit it. And so it's a nice way of protecting yourself from accidentally modifying or deleting a file that you don't want to. Now, I would argue for the most part, this kind of nice syntax of describing like G plus or G minus something is probably the way that I would think about you accessing chmod most of the time. I do want to mention that this is out there and you see it a lot. There's another way of using Chmod that some people really prefer, but I think is a lot harder to read, which is this thing that uses numbers to describe the permissions. So it uses this thing called octal to represent a number between 0 and 7 inclusive. And it uses a number to represent each of these things. So the idea is you can represent this RWX thing as 3 bits. 3 bits can represent the numbers 0 to 7. And so you associate each setting of those 3 bits to one of those numbers 0 to 7. And then to specify the whole permission on the whole file, you have to specify 3 numbers. Each number corresponds to user, group, other, and each number contains 3 bits. Owner, group, read, write, and execute. Sometimes you can remember this by 4 for reading, 2 for writing, and 1 for executing. And so if you want to give read, write permissions to the owner and everyone else gets nothing, you'd say chmod 600. 6 because plus 4 for read, plus 4 for plus 2 for write, and that adds up to 6. And that's going for the first number for the owner, and then 0, 0 for everything else. So this is a much more succinct way, in some sense, of getting it. So if you know the numbers off the top of your head, this is really useful. I don't memorize these numbers. I usually just use the G plus X syntax. But I wanted to give you a chance to practice this and see this, because you do see this out on the internet quite frequently. It's a nice way of ensuring all of the bits you want are set. Because remember, that G plus X syntax only adds or removes something. It doesn't ensure all the other things are set the way you want. And this is a nice succinct way to make all of the bits set in one command without having to check what's there already. So I want to give us a chance to practice this changing the permissions. So what I want you to do is, using that first way of Chmod, using those letter codes, I want you to make the command that allows the owner and the group to read, write, and execute, and others to read the file, but everything else should be unset. So take a minute, try typing out the command for how to do this. Okay, so hopefully you had some time to work on that. Let's go ahead and try this. So I'm going to go ahead and switch to my terminal. And so if I want to add read, write, and execute permissions for the user and the group, I could do something like chmod. It turns out you can actually modify multiple things at once. So you could have written this out more verbosely, doesn't really matter. But if you type UG here, that's modifying both the user and the group. And then I want to add read, write, X to them. And then if I also want to make sure others can read, I could do others plus read. Now remember, you could use this multiple syntax to set multiple things at once with the comma, and you don't use spaces here, which is kind of weird, but you just don't use spaces there. And you could run.sh. Now this could work, but one of the downsides of this approach is it doesn't make sure that the others can't write or execute, because it ignores those other permissions that we haven't set or we didn't say to set. We just get whatever is there. So to be really, really explicit and make sure that the others can't write or execute, you have to actually make sure you remove them. So you want to say something like remove write and execute from the user, and then run this. And then you can always check to make sure that run.sh, or whatever file you want to modify, you can see it has RWX, and then just R for the other group. That's the idea. Just modify the permission. You'll get lots of practice with this on your next assignment. Now, I want you to actually try one more thing just to practice it once, which is how to do it with the number way. So using the kind of 3-digit numbers. Take another minute, try the exact same problem, but using this numeric approach. Okay, so hopefully you had some time to think about that. Let's go ahead and try this together. So if you want to go ahead and do this, remember that the kind of weird numeric system, and I would do this with the slides open if I didn't have my notes in front of me, which is reading is +4, writing is +2, execute is +1. So if you want to give them read, write, execute, that's associated with the number 7. And so you could do something like Chmod, 7 for the user, because I want to give them read, write, execute. 7 for the group, because I want to give them read, write, execute. But for the everyone else, I only want them to read. And so I'll use the number 4 there. So now you can see here, I get the same output. So again, it doesn't in some sense matter which one you use, it's just a preference. But I just want to make sure that you're comfortable with both, because you see them both out there kind of equal. So the last thing I want to talk about in this video is kind of getting back to a question I kind of paused on earlier, which is, it feels a little weird that I have all these files in here that are globally readable. Does that mean anyone, including you, can go onto Atu and like view my files? And it turns out no, because there's one extra bit of the story I didn't talk about, which is directory permissions. So directories themselves have permissions. So even if a file might be globally readable because it has the other flag to set read, if the user doesn't even know the file exists, then they can't read it. And that's kind of where the directory permissions come in, is helping you answer whether files exist or not and who has access to directories. So the D flag on this kind of permission things tells you whether it's a directory or not. Now, if it's a directory, read, write, execute means slightly different things. They have a lot of the same intuition, but they just mean ever so slightly different things. So if you're able to read a directory, it means can you ls it? So can you view the contents of the file? Or sorry, the contents of the directory. So if that directory has the read bit on for a particular entity, user group, or other, they're able to ls it. They're able to see what files are inside of it. Now, for the files inside, they have all their own permissions that we just described. But the directory permissions for reading is just, can you ls? Can you view the contents of this directory? Writing is about whether you can add or delete files from a directory. And executing is whether you can cd into it. So if you can actually jump into that directory. And so you can see here, if you go look at my home directory, I'm going to do ls-l and then grep for hshaper. You can see here that the directory for my home directory on Atu only has read, write, execute for the owner, which is me. No one else has access to it. If I change this to have read access for everyone, then they can see all of the files that are inside my directory. There are cases where you do want these public directories, namely our course website file, right? So if you look up here, you could see that all of our kind of files for all the different quarters, you have access to read and go into it, but you don't have access to write to any of those files because we want these things to be publicly accessible. But my private things in my personal directory, I don't want anyone else seeing, so I don't change the permissions to let anyone else see it. So that's just the one extra complication here, but it's very, very similar to what we saw before. And so that kind of wraps up all of the kind of miscellaneous things we were talking about. Users, groups, processes, settings in your bash profile or bash RC, and then finally file permissions and directory permissions. These are a lot of the core concepts that you use throughout your Linux experience. And so hopefully this gives you a language to talk about kind of how to customize things in the way you want for whatever application you're working. Hopefully I'll see you in class where we can talk about this stuff, answer questions about this, because there's a lot of interesting things here. And so with that, that's all I have. And so I'm going to sign off.